Hey everybody, quick little recording on uh, starting to get into suspension systems. So I'm going to go ahead and share a PowerPoint with you and we'll start our little presentation here. So, all right, let's get this actually into the slideshow mode. There we go. All right, so um, what I wanted to go over is just a basic overview of the suspension system, and then we'll kind of break it down week by week. Next week, we'll kind of break it down to another system, but I want to kind of give an overview of everything that we're going to be working on in class during our labs. Now, you understand this is a hybrid class. You'll do part of it online and part of it in the actual lab, and your lab instructor will guide you through that process too. So let's go ahead and get started. I want to, start off with some just basics. Uh, they put in the PowerPoint these objectives, and these are kind of things that you should take away and understand by the end of this presentation. If there's any additional things, please feel free to contact me if there's some clarification or thing on through Canvas inbox, and I'll be more than happy to help you out. So, basically they're talking about the different suspension systems, and because there's not just one, there's different ones, and they've evolved over the years. So, uh, and also get into the various types and suspension systems and explain how they interact with other vehicle systems, because it's not just one piece. Because the it really, the suspension system is really part of the braking system too. If you really look at it, if the suspension system, braking system didn't work properly, you would have all kinds of swaying, all kinds of possible accidents, really. So, and then I'm kind of look at the different body types. You'll hear things like you know, frame type systems, unibody type systems, and then we'll get into a little bit about powertrain, how that all comes into place too. So there is definitely a need for a suspension system. You look at early on, uh, they, just a set of springs. There was no shocks or anything like that. It really was very basic. And if you went over a bump, of course, you really had a lot of suspension movement going on. And then, of course, part of that is steering the vehicle too. And then, and then their development has actually changed, gotten better. We have all kinds of different systems that really make it more comfortable. And nowadays, we're kind of, well, we have been, I shouldn't say nowadays, we've moved primarily away from hydraulic steering or manual steering, well, even manual steerings too. Uh, we went into electric steers, so we'll talk a little bit about that as we go along, and then we'll actually bring that over to its own little section as we go. So vehicle frames and bodies, how they were put together, why they're put together in a certain way, and then we'll talk a little bit about the powertrain types that you have, like the rear wheel drive, front wheel drive, and like that too. And then we'll get into a little bit of the electronic controls that are in the steering and also the suspension system too. So there's a need for the suspension system. No road is perfect. Of course, potholes and all that kind of stuff are part of it, and some of it we can't really control. But our suspension system make it a little more comfortable. And again, they're, like I said before, the braking system, the steering systems are really kind of together, and they really interact with each other too. What over the years, what has changed is a lot of what the shock absorbers. They were some basic oil-filled shock absorbers early on, which we'll get more into it. And now we have different shock absorber systems out there. And like I said, when we get into shock absorbers, we'll get deeper into it. So without a suspension system, of course, the wheels, and the frame, you would have transmitting the shock right to the passenger, and there would be a lot of vibration and bouncing. So think of it, if you just took the shock absorbers off your car and just drove it down the road, of course it bounced a lot more, and that is one symptom, believe it or not, of bad shocks. And I'll go through a few as the semester goes along. I'll go over a few different types of tests that you can do, and without a type of suspension system, wheels pretty much wouldn't stay in contact with the road too. Part of that is when you bounce, it doesn't really have a good footprint on the road, and you can actually lose control in it. And again, we can go into accidents because of that too. So during turns, the tires, of course, have to make contact with the road, that little bit of grip to make it turn. And then there has to be a proper angle for the tires, to actually make that contact. And if we have a suspension system problem, whether it be a defective part or an accident has happened, and we can actually have the wheels not in alignment, but alignment's part of it, but then again, there's also the contact of the tire too. So it is important that we know that this is important for driver comfort and making it minimal. If you think about it just in your head, if you have manual steering, it's going to take more effort. And then if we, like I said before, take the shocks off it, that bouncing is going to make it more accident prone as we go along. So it really is important that they all work together, with the steering, the suspension, and the brakes, and even the powertrain too. So we'll get more into this as we go along through the semester. So without proper steering, you're going to have some noise, you're going to have poor handling, you're going to have excessive tire wear too. You're going to be scuffing it as you do your turns, and that can actually cause, if you look at, and I don't want to say this in a bad way, but if you look at people that really dive into the corners and they don't have a very good suspension system, you can actually get kind of scuffing. You can notice that a lot of times on the front tires. Not so much in the rear tires, but on the front tires, you'll see a lot of that scuffing going on. And that's where it's actually, when the tire goes in and grips in a turn, it will actually wear. And that will cause more wear in the tires. Of course, you have to replace tires more often. You'll have a lot of noise going on too. And after a while, you're going to get pretty much a lot of poor handling. Because tires really do put that grip on the road. So we want to make sure that doesn't happen. So kind of going a little bit back to the covered wagons and stuff like that, they really didn't have a lot of comfort to them. If you look at the picture here that we have, you just see a spring. Do you see any shock absorbers anywhere? No, you don't. And here's the fancy braking system you have here. We actually have like a paddle that goes on the wheel here. So this wheel, this is just a really basic one. This one doesn't even have the rubber on the outside of it for a little more cush on the road. So this really bounced quite a bit when you went over the road. So this is early on type systems we had. Well, they had back when, I should say we. So early cars pretty much had a leaf spring in place, and that spring, it was kind of, well, there's different ways. There can actually have one that goes from the axle across, where we could have a one going across this way from wheel to wheel, or we'd have one going back. So they'd have two leaf springs versus one, and that would support the vehicle. And there was early on, they had what they called kingpins. These kingpins were a solid bar, and the wheels would move, kind of going together, through the steering mechanism. And this really was very, very basic. You we really didn't have a lot of comfort. Let's put it that way. And it would actually, and these are, these are still being used in some of your heavy-duty trucks. They'll use a kingpin versus other types of suspension systems as we went on. So, just a little bit of history here. So, in the 1920s, we had low pressure tires. They were kind of almost like little balloons type thing, and replaced by skinny, high pressure tires. And then vehicle wheelbases increased, and we'll get more into the wheelbases when we start talking about alignment, which is very important that we know those measurements to make sure that the vehicle is square, and we'll get more into that as we go along. So independent front suspension systems were introduced in the 30s, and we had a double wishbone type suspension systems. We had control arms and springs. As you can see in this picture here, we have an upper control arm, a lower control arm, and then the spring is in the center. So this is the beginning. So they were called, short, long arm systems, or SLAs, and these were considered the conventional suspension. And there was a knee action type of thing, so it would move up and down, replacing the direct act, which was just kind of boom. It really didn't have a little bit of, it made it a little bit better for several reasons, and we'll get deeper into this as we go along. So these the SLAs, or short long arm systems, used pretty much in the 40s. SLAs used for 30 years as we went around, and it was pretty much standard for these to be this way. We have evolved. Some of it is actually changed, which is a good thing because it gives us a little more stability in handling as we went down the road. Now, other things that did come into place too was they started with ball joints. If you remember that picture before, there was that kingpin, and it was a solid pin that went and connected the wheels so they could turn. Now we have a little more of an independent going on. And then what they added in was ball joints. These ball joints, instead of having that pin, now we have a separate connection, and that helped with making it that able to pivot a little bit more. Some vehicles actually use torsion bars instead of a front coil, and we'll get into that as we break that down through the differences. But remember, this is just an overview of the things, and we'll get deeper into it as we go along. So ride control sometimes could be an air suspension. They were actually introduced, and sometimes you'll hear things like airbags, or you'll hear I have an air ride system and stuff like that. These were quickly, kind of abandoned. The Lincolns and some of the Cadillacs were really famous for this, and they did have airbag problems, and those airbags were not cheap. I remember working on them myself. There was cute ways of diagnosing them, which if we have time I'll talk about that too. But they definitely, if you had an airbag go bad, um, they were very expensive, and it was not hard to actually cause a problem with the airbags too. There was certain procedures you had to do, and we'll talk more about this as we go into um, the specific areas. When we get into shocks and stuff like that, we'll get definitely into that too. So in the 60s, they started off with the Mcpherson Strut systems, which really were an improvement, uh, but they were pretty much on the import side. We really hadn't adopted them in the States here yet, but later on, we did start adopting it, and believe me, it is better for the smaller cars and trucks. When we get into heavy duty equipment, of course, you take and when you go into trucks and heavy duty stuff like that, you're taking some of the comfort away, because remember, it's a truck. It's not a car. It's an actual truck. Some of the trucks are very comfortable, but you can know that feel as we went along like that. So in the 70s, independent rear axles more common. Before we had a solid rear axle, now we have independent systems coming in, which made it a lot more comfortable and a better ride and better handling. Air operated suspension systems are reintroduced using more dependable controls, and we didn't have to go through these different procedures. Some hydraulic control systems adopted, and then of course the electronic control were actually introduced, which made it definitely you could get into sport. Sometimes you'll get a car that has the sport steering, the sport suspensions, and this really helped with actually getting a better control of the car itself. Or you could have nice little cushioning, easy ride on it. So it's kind of stiffens it up when you want to go into the more performance type suspension systems. So earliest steering systems used, tillers, and actually, you just had a little handle, and then they went into the actual steering wheel, which operated similar but not exactly the same. So on our steering systems, the tillers worked really good for the smaller stuff, but when it later on, for the bigger stuff, it was you really had to have some arms to actually get that to move back and forth. By the 40s, all vehicles were using a parallelogram type steering system, and like I said, we'll get into these different systems as we go along. In 1952, power pistons started being used to get it a little more, so you didn't have to be a bodybuilder to steer your car around. There was actually hydraulics were actually brought in, and then we went into gearboxes, and then the linkage to attach to that too. On later versions, the gearboxes contain, instead of that just the direct gears connecting, they started doing some valves and power pistons that were added into it. Power steering common by the 60s, you still had that option. You could have in the 50s, you could have manual steering, and it was not as actually as common to have power type steerings or power assist type systems, as they called some of them. And then rack and pinion systems were adopted in the 70s and the 80s, which really brought a little more simpler. And I want to say too that it really helped with the assisting. You could have a manual rack and pinion, or you could have a power rack and pinion. So most of your cars now actually have a system that actually helps with the controlling at different speeds too. So, and some of them are actually computer controlled electrics. And then we went into the computer controlled electric motors instead of hydraulics. So most of the cars you're going to see today, these days, and probably pretty much everything in the lab except for a few are going to be electric steering versus the old hydraulic type steering. So front suspensions, most vehicles have independent, front suspension systems. So each wheel works independently. So instead of old days, you would have a solid axle. So anything that moved on this axle affected this axle over here too. So you still had that movement. Now, when you go over a curb, well, hopefully you don't, but when we hit bumps in the road, we have that independent going on instead. So there are definitely two types of independent systems. Of course, the Mcpherson Strut, which is getting what is most common, or the short long arm type systems where they have independent all the way across. So this is just some of the different ones that they have in place, and we've turned those into electronic suspension systems too. We'll talk more about that as we get into that part. So Mcpherson Struts are getting more and more to be in the. They used to be pretty much on the front, and then you had a regular shock on the rear, and now it's getting to be where all four wheels have that Mcpherson Strut. It connected up to this the next page I actually have a slide. I mean, it shows how it kind of connected. You don't have that upper control arm. Now you could actually have a hybrid, or it actually has a control arm and then a Mcpherson Strut and a lower control arm. But what is probably most common is a Mcpherson Strut going up to the body, mounting to the body, and then you just have a lower control arm. They can actually make the lower control arms a little bit smaller this way too. So, and then of course, the way they're connected, they're fastened to the strut is actually to the body, and then like I said before, and then it actually goes and connects to the control arm on the very bottom. Now this is like I said, most common type of system we had. If you look at most of the cars out in our lab, you're going to see the Mcpherson Strut, and then on the front, and then a lot of times you're going to see the Mcpherson Strut on the rear. We'll break down how the strut really helps out as we go along. So most single control arms, like what you have here, this is actually attached here at the steering knuckle, okay? And this is showing a front wheel drive or even a rear wheel drive too. It could be a rear wheel drive also, but you have a ball joint below, but notice there's no upper ball joint like we would have on a short arm, long arm type system. And then steering knuckle is connected to the wheel bearings and the brake components and all the wheel and the tire assembly. So if we go to this kind of joint here, if we look at it, it helps with movement up, of course, up and down, but also when we are actually in the front of the vehicle, it kind of allows it to pivot a little bit too, where those kingpins would actually be at a certain angle, and they didn't give this movement, they only gave this kind of movement. So that was the advantages of going to an actual, independent suspension systems as they did later on. And then we have the short arm, long arm, like we talked about earlier, had that pivot motion going on. So we had an upper control arm, a lower control arm, and then we had a spring mounted either on the very top of the upper control arm, or we had the spring in between the upper and the lower control arm, which usually the spring was attached to a body, or some kind of a body component like that. And then we go into the torsion, like I said we would do a little bit later on, But we had a torsion bar that went, and it actually, instead of having that spring, that coil spring going up, we actually had a bar that was actually twisted, and that would cause a spring action. So we connected that to the frame, which you see on the back here, the frame back here, and then we connected it to the lower control arm, okay? And that, when we twist that bar, we actually put a little bit of a springing action to it. And this is another way that they did on, some of the SUVs had them, also some of the trucks had them. There was actually in the 70s, 1970, that is, they had some actually cars that actually had them. My brother actually had a Dodge product that actually had torsion bars, and it really made it a lot easier for him to lower his vehicle. He would actually release the pressure on it, but then it gave it a very bad ride. So you when you start lowering without taking in consideration the different types of comfort level you might have, there is a correct way of lowering a car, and there is a not correct way of lowering a car, and I'll try to cover that as we go along in the semester. So the short arm, long arm systems, they had bushings in the arms. They also had, the ball joints. So these are some of the parts to it. And here is the bushing on top. Here's a bushing on below. These were all attached to frame pieces. And then we had our upper ball joint and our lower ball joint. And here's your steering knuckle, which is connected to the wheels, to the brake systems, and also to the bearings. And then you're going into the rim and the tire as you go apart and you go across. And then they have another little guy up here. We'll talk about this guy as we go along, this sway bar. Okay, and this is another way of making the steering a little bit better. I should say the ride a little bit better. And of course, shock absorbers are separate from the springs and the short arm, long arm systems. When we get into the Mcpherson Strut, they're kind of combined into it. One of the shock is to the frame. The other one, of course, helps. We put it on so we can get that vibration, that oscillations from being so hard on the driver. If your shocks go bad, you're going to get that bouncing all the time. Or we could go to the other extreme where the shock gets stuck. And it does happen. There's some valving inside the shock absorber. We'll talk about that as we go along also. And then in the rear suspension, this is where we went from independent, from a rear solid axle. So we could have a rear axle, solid axle, and it could be an independent suspension, a rear axle too. And we'll get more into those as we go along. This was very, it really was very beneficial as we go along. The flip side of that is now the rear suspension systems are, we could have alignment issues. Well, not that we wouldn't run a solid rear axle system, but we can actually adjust on the non-solid systems or the independent systems a lot easier than we could do on the solid systems. If you had a solid axle on the rear, there's not so much you could do with them, but now we can actually adjust different angles on with the independent systems. We can actually adjust the camber and the caster. Camber so much, I shouldn't say caster, but the actual camber in the toe. That's what I meant to say. So this is a way it made it a lot. The tires wear better. You had a lot better tracking control on it also. So we'll get into that too. And it, pretty much was on, a lot of the um, a lot of the cars in light trucks, SUVs. So it says here most trucks and SUVs will use solid. Not so much anymore. We actually have additional uh, cars that actually have, which are some of the light trucks and some of the SUVs have that capability. Some of the high performance and large cars also can use a solid, or you might see of them actually um, use an independent type systems too. So the rear suspension system components, they're of course, depends on what kind of car you have. We could have independent suspension systems. We could have a solid axle on the rear, and we'll identify that as we go across. And then there is the air, shock systems that we'll get more into when we get into our shocks, and then we'll get into the ones that have the onboard compressors, and we'll actually have some of the systems actually are electronically controlled too. Okay, so yeah, I pretty much covered this little section here. You don't really see the torsion bar systems anymore. They've kind of gone away over the years, but you might see one pop up if you start working at older cars. So, getting into more independent rear suspensions, this is getting to be the norm, and you'll have like a lower control arm, but you'll have a Mcpherson Strut. Uh, so it almost is the same as the front, but now you're actually either being driven, or it gets a little bit different as we go along, or sometimes they call them a dead axle, or a solid axle system on the rear, which can be very, very pragmatic, because I've come across where the actual solid axle snaps and breaks and like that, and there's a lot of noise in the back, and then your car really looks it feels kind of squirrely, because now you got the wheels kind of moving around, or there might be a little crack in the rear axle. That it could happen. I'm not saying it will happen, but if you get the solid rear axle systems, this can happen. You might see that too. All right, and solid rear axle systems, I kind of went over that a little bit. So they're not as comfortable, I'll put it that way. These systems pretty much are, like I said, this is pretty much a driven rear axle assembly here, and you will see this in some of your trucks, of course, some of your SUVs, some of this is going to be front wheel drive only. If you have a four wheel drive, all the time four wheel drive and systems like that, you could have something similar to this. And here we're showing springs and shocks on this particular one, and then we have an actual leaf spring. So I really didn't have a good picture of that until now. Here's the leaf spring systems, and this is a coil spring type system here. Now these coil spring systems could be airbag driven also, or you could have air shocks on the rear too. So there's different types of shocks, and not just all hydraulic type stuff. And then, of course, steering-wise, steering components, rack and pinion is probably the most common now. And then we have conventional type ones where we have the bars going across. We'll get deeper into this. And then power steering has been around for years, whether it be hydraulic or now more readily it's going to be electric. And then we have some vehicles that are actually four-wheel steer. So all four wheels work together to actually make the car going down the road. and actually get into, some of these will actually help with parking uh, and going around corners too. All steering systems have common components, of course, and the steering wheel size is designed to provide mechanical advantage without being too large. Uh, the way, again, well, we're just going an overview on this, but I think what you're going to see more often now with the steering, it's going to be more of a rack and pinion with electric steer. So this is going to be more of the most common like that. And then you can have sports steering and regular steering too. So rack and pinion steering is pretty much the most common, but you can still see with some of the conventional type steerings on some of the larger trucks and the larger cars and trucks and like that. So our rack and pinion right here is kind of the most common. This is showing a hydraulic type or a manual steering. It could be a manual too, but it actually has a set of teeth, all one. So you're right. What's happening right now, right on this end, is going up to the steering wheel, and then we're taking a twisting motion, and we're converting it to a side-to-side type motion, like that. And here's showing with the steering wheel connected. So the steering wheel comes down and it goes into a knuckle assembly down into your rack and pinion as you go across. And we'll get more deeper into this as we go along. And then our old conventional steering boxes, which were, again, this is just one way of doing it. And this is what was done for many, many years. Not something that happened overnight type thing, but this was the would be added in with the kingpin systems, and also it would be added in with the the short arm, long arm type systems. Very, very common. Like that. So here's the actual gear. So we're going to take and move, again, we're going to move it back and forth, but we're going to do a little bit different. We're not going to have a solid tube going across. This is going to actually use linkage. And which, again, the rack and pinion can fail, of course. There's different, I'll talk about them as we go through that specific section, but there is definitely problems with both sides. Now, one of the biggest problem we have with the conventional type one is all this linkage. Everything here can be wear. You can wear, and you can have link problems. You can have, here we're going to get into the alignment section. We'll talk about this guy and this guy here, but we have more ball joints to worry about. Not just the ball joints on the control arm, but now we have some other ball joints, and these will actually wear after a period of time. And you have to be aware of it, how to test them and then check them out to make sure they're not too worn, because after a period of time, these will wear out. And it happens. So we have different parts going with it, and we'll break it down as we go along. So most, not so much anymore. It's saying most power steering systems are hydraulic. They're getting to most of them are getting tight to electric. And there's a different type of system, but there are still some stragglers along the way that use the hydraulic type system too. A lot of your trucks are still using that also. And there's different types, and I'm going to go into the conventional type right here, and then the rack type, and then we have an integral where it actually uses a piston to actually move that around versus just the gearbox being fed like that. And then we have four-wheel steer. We have another rack on this particular one on the back, and it's actually using it to move those rear wheels too. So this is usually controlled by electronics, not so much anymore. There's a few vehicles out there that do have, but I've only seen it in some of the trucks. Honda was one of them that early on used the four-wheel steer. which, you know, it was something. It did help with changing lanes, and it did help with parking and stuff like that too. So, and vehicle frames and bodies are unique to the different types of, you know, systems you have out there. So there's two major types. There's the body over frame, and then the unibody, which is the most common and smaller. And even some of your SUVs use it. Light duty trucks might use it also, and there's a reason for this. You know, body over frame. There was a solid frame. When you got into an accident, this actually transmitted a lot of the accident to the human body, and there had to be a better way of doing it. So there was the unibody that came into play, and unibodies are made to actually crumble, take a lot of the energy from the accident away from the human body. So these were pretty much why it went that way. You still see some of the body over frame on some medium duty to heavy duty vehicles, you know, like some of your big trucks like that. And you get into transporting, you know, transporting things like heavy equipment and stuff like that. You need something a little more sturdy. Whereas a car body, it really does make fit to use the unibody type system. And, you know, our body over frame, like I talked about, it was a frame that was a tubular type, and then it would actually be have the body bolted right on top of it. And we did this for many years, and then, you know, of course there were some studies done that, you know, anytime one of these cars got in an accident, it would cause a lot of transmission of, you know, the accident to the human body. Now these were actually not just mounted solid onto the frame; they actually had little rubber cushions that pushed them down into place too. And I think, yeah, this is pretty much what I was talking about in just a little bit. So late model, they kind of, you know, they still use them, the body over frame, but there's still some that they're gone away. And this is pretty much what that looks like. The vehicle, you know, here is the frame, then the body would be mounted on top of it, and making it really sturdy, let's put it that way. And this was with conventional systems. You had solid rear axles a lot of times, not so much on the end of independence systems and like that. So this was pretty much what we started off with. And then in the 30s, they introduced the unibody. Now, what you see different here is no frame. Actually, part of the frame is built into the body itself, and it's welded in, and this is where it can get that crumpling, or that, you know, when you go in a crash, you can actually move the body to keep some of the energy away from the human body. Now, don't think it crumbles all across, because there actually is almost like a roll cage that's welded into here. This roll cage keeps it from you getting really hurt. Now, different designs do different ways, but that pretty much is, it's very common for the reinforced around the human, the passenger and the driver, and then, you know, they'll actually reinforce it for the engine, the drivetrain, and the suspension systems. So it's not just, well, it sounds, what I explained it earlier, like it just crumbles up. No, there's still some really nice sheet metal pieces that are actually stiffen it up for different places that will be common, that would need to be this way, like that. So it, you know, the unibody has mounting surfaces for the Mcpherson Strut. It you know, more of a rigid, it does have a rigid body, and then it absorbs, shocks and transmits it in the entire body, entire vehicle. Lighter and stronger body types, harder to repair when damaged. You really need to get a really good body shop to do this if you have a problem with an accident, because some of it is, the total takes too much to do it, because you have to have a special machine to straighten all this stuff out if you get into an accident. You can actually look under and inspect. I'm going to encourage you to do that before buying a car. Raise it up, start looking for certain areas that look like they've been cracked. And we'll get more into pre-inspection for alignment as we go along, but I always check my wheelbase and my track base to make sure the vehicle is square, and if it's really off, it's been into an accident. So unibodies, they have mounts for the engine and also the transmission as we go across. And modern unibodies are rigid in the passenger compartment area, like I said, for like that little cage. And hood and deck areas contain kind of crumple zone areas. So your hood up front and your, on the back there, you're allowed to collapse when you get into an accident. All right. I think we're going over and over and over again. So here's what I'm talking about, this little area right here. Okay. That subframe going on. And I am, all right. I think I'm going to stop here for a second and we'll come. All right, folks, back at it. Wanted to go a little more over what we've been talking about. And, the unibody, of course, we've been talking about it. Now, the other thing I want to talk about is center of gravity of our actual vehicle. And this is important when you're lifting it. Like we already talked about, making sure it's on the rack properly like that. But that's not the only thing. We want to proportion the weight of the vehicle half and half, but it doesn't always work that way. So we do have, the lower it is, it's more stable. It looks cool too, right? And if it's too high, then it's possibly tipping over. They had some vehicles that were very prone to that. If you get, you've seen the monster trucks kind of lean over and stuff like that at some of the meets and like that. But the ideal thing is to have the center of gravity and kind of the center line of the vehicle like that. But as we know, we have front-wheel drive vehicles that have all the weight, the transmission and actually the engine together. That's going to pull a lot more weight on it, whereas the back is very, very light. So when you're lifting the vehicle, of course, you have to take that in consideration because you don't want it to tip off the rack. But most of your weight will be front, so that center of gravity change, and that center of the actual lifting is there. But also you want to take into consideration the height of the vehicle too. So not so much on lifting, but how we design the suspension systems and the braking systems like that too. So getting a little repetitive here, I apologize that, but there's different types of rail systems, the drop fail rail systems, and then we also this allows the engine to and the drivetrain to be kind of installed close to the ground, which gives it a little more stability too, and the weight location lowers the center of gravity too. So we had those low hood back in the day. We had the hood up here, and then the whole engine was up here, so that makes it a little takes that center of gravity off like that too. So types of drivetrains, if you've taken any classes, you probably know this already, but we do have front-wheel drive, rear-wheel drive, and four-wheel drive. So depending on the car that you're working on, you're going to have these basic type systems like that. And the four-wheel drive can be different types like that. I think the front-wheel drive and the rear-wheel drive are pretty straightforward, but the four-wheel drive can be a manually connected, where you actually have to either do a gear shift lever, or you have to physically go out and move some hub plates to make it go into four-wheel drive. Or you could have systems that actually have four-wheel drive on demand or all-wheel drive, all the time like that. So it actually picks up what wheel is not connecting properly, and it makes it a little more, able to grip in and actually work it like it should. So these drivetrain problems, of course, definitely vibration, pulling, noise. So technician concerns are, vehicle drivetrain, servicing the drivetrain parts like that. So front wheel drive, probably the most common on small vehicles, minivans. Not always. I mean, there are some vehicles that are four-wheel drive, or I should say front-wheel drive, that are on some of the light SUVs and some of the medium, so also can be on some of the large cars. Not so much truck, but large cars. So these are kind of your common things. So commonly, the front-wheel drive is going to be a front engine type, transverse type, and the engine and the transfer is going to be up front. And instead of being straight this way, but some vehicles can have a straight, like some of your Subarus and stuff like that. The engine's here, pretty similar, but most of them you're going to see on the light ones are going to be turned sideways like that. And this is kind of showing, here's the transaxle, and the engine would be on the back, right here. I shouldn't say on the back side. That's the back side of the transmission. But you would have an engine here, and then we have our drive axles going from one side to another. So you have two drive axles going on. And then you have your steering components. We're added those into it. And here, the engine, see, this is actually showing a longitudinal type mounted engine like your Subarus and all. And then here is the transaxle. Now, and this is where it gets, you really need to know how the transaxle system works too, because folks, I'm going to tell you, on occasion, you'll get customers to say that, hey, I think I need a wheel balance, and it's really not that. It's actually the way the actual drive axle is doing that, making that vibration too. So you've got to be you have to understand how that works. And I recommend that you take, to further your knowledge, I'll try to show you some tips in lab, your lab instructor will show you tips in lab, but what we're going to do, let's put it this way. The vibration could be wheel vibration, it could be a axle vibration, it could be a simple, it could be motor mounts. If the angle of the drive axles isn't right, that can actually cause a vibration also. So we'll go over this a little bit more as it goes across too. And then the way your CV joints are put together, they're not just one solid. They have to be able to pivot. Okay, so when they pivot, they actually have to be able to move this way, all ways like that. So there's different types. This is the ball type, and this is actually a tripod type of design here. And here's one of the things I would encourage you to do, and I don't see this, I always pick about, but is make sure the CV boot is solid, not rips, tears, grease falling out of it or anything like that, because this is where the lubricant is to take care of all this. So this is a CV joint that gets lubricated, and this kind of contains it in. If you start seeing some marks on the frame or around the transaxle and stuff like that, you know this guy is leaking, and you want to make sure you replace that boot as soon as possible, and because it keeps out water and actually dirt at the same time, keeping it from getting get moisture and dirt in there. They take dirt and put it into a bearing. Of course, you know what happens. It's like a sandpaper going in there. You get moisture in there. Now you've got water contamination that breaks down the lubricant, and also it can actually cause the bearing materials to actually wear out quicker too. And then the front wheel drive knuckle, steering knuckles. We've kind of showed some pictures of that just a few minutes ago, but you could have potential problems, either the suspension systems, clearance problems, and one of the things, when you're lowering the vehicle, you got to think about the shock travel too. Shocks are made to have a movement, and we'll talk about this a little more. So they have a travel that goes up and down, but if you lower it, that takes that travel slower, and sometimes it can bottom out too. So this is one of the things I want to make sure that you understand. There is a correct, with drop spindles and stuff like that, you can actually lower it. There's kits to do that correctly, instead of just, like my brother used to do, just release the torsion bars. And the other thing that was very common for my day was you would actually cut the springs. That would drop it down a little bit, but there again, you're not getting that travel on the shock anymore too. All right, rear-wheel drive vehicles, of course. There's been, there's actually, it has been. It used to be everything was rear-wheel drive, and then things went to front-wheel drive. We still have some of them on some of the medium and heavy duty, well, definitely heavy duty. Some performance cars and some full-size vans will use a actual, rear-wheel drive kind of configuration. And this is pretty much what we're looking. So instead of having two axles on the side here, which is again, you could have four-wheel drive. Don't get me wrong, but we have an actual tube, and this is what's considered a drive shaft. Now, this drive shaft has universal joints, which you see right here, which are a wearing point too. They have little bitty boots. You can't really see that, but these boots are again trying to keep all the dirt and moisture out of it. But these tube could be either metal. I've seen some of them composites. I've seen different designs of these tubes. This is definitely a balance issue, a concern. I don't want to say issue, but I want to say a concern. This, if you're doing a U-joint job, you want to make sure you take care in clocking it correctly. If you take it out a certain way, because that drive shaft's been balanced from factory. Things can happen. Don't get me wrong. There's weights that are usually on that can fall off. Normally they don't. If you get it hit, bent, you have a big problem. You're gonna have that tube replaced. And there's a couple of shops out there. Driveline Service is one of them. I remember that I used to use all the time. I'm sure they're still in business, but they would actually take it out, change your joints, and also balance that tube or replace the tube if needed be, because I always use them instead of doing the tubes myself, because you get some of these yokes, what you see here, this little slip yoke, you get some of these, and you get some people that are just using a hammer and a bar to actually drive them in and drive them out. Then they expand this, and that puts the balance off. Or they don't clock them properly. They didn't take them off and put them back on the same way. And there again, you have a balance problem afterwards. If I just send this whole unit out, what can happen is this whole unit's going to be balanced, and the joints will be actually replaced at the same time. And realistically, liability-wise, it takes a lot of the reliability off you too. There are longer cars, I should say trucks, that use a dual drive shaft, or some of them I've seen actually 3 drive shafts. So these are what they call two-piece drive shafts. These drive shafts go from that transmission up front all the way to the back, and this is not uncommon to have 2 drive shafts in place. And then most drive shafts use a slip yoke because it needs to be able to move in and out with the body flex going on. If it was solid, it would definitely cause some cracking of the drive shaft, maybe even other problems. And this is can happen. These slip joints actually need to have enough movement, and if they're damaged, or if they do not have lubricant to move them back and forth, that can cause a problem also. And rear-wheel drives have a differential in the back, and this differential rear axle takes that movement from the engine going back, well, I should say the transmission going back, and then it takes that movement this way and transfers it to this way. And it's all done through a ring and pinion set like that. So here's just showing, because when you're going around a corner, not both wheels don't turn the same rate. So we need to have a way of moving the outer side moving quicker than the inner side, and through that we do it through a differential through some side pinions that we use to make that happen. And this is rear-wheel drive, kind of showing one kind of system with the actual struts on it. Okay, and again, this is using a differential in your drive shaft, and you'll see control arm. Okay, and then you've got a couple, lower control arm, and then you have the disc brakes, the CV, and this makes it more of an independent suspension too. So instead of having it drive the complete solid axle going out, this actually will allow it to move just like it did in the front. It's going to be able to do it in the rear also. Then you have four-wheel drive, and again, like I said, there's all different types of setups that they have out there. So almost like 2 differentials on this. This has got a transfer case on the transmission actually. Now there's different ways they can do this too. This is just one style. You can actually have the transaxle up front. This is showing like a rear wheel, it's showing like an engine up front, differently. But this has the transfer case right here for the front wheel engine, front wheel, and then it can actually have another axle going straight back to the other side too. And four-wheel drive steering knuckles, again, it really depends if it's a independent or a solid rear axle system. And this is just one style that they have here. So here we have the front, almost looks identical, but notice the axles are, the short axles are on the outboard, and that makes it easier for it to move up and down. And then we, it's kind of an exploded view of all the parts that are inside of it. A lot of pieces and stuff like that. And this really depends on what kind of system you have. This is again a good reason to take a transmission class. And they go a lot more over this kind of stuff too. And then electronic controls are used all over the place, folks. They're used for your fuel systems, your ignition system, charging system, emission system, transmission system, air conditioning, cruise control, brakes, and also steering and suspensions. So there's all different ones. Then you go farther into your navigation systems, your accident avoidance systems. These are all going to be electronic also. And this is just showing a vehicle that actually has electronic suspension systems for that ride control. And they have little, solenoids and sensors to actually control, make sure the ride height stays a certain, give you that stiff feel when you want to go into a more performance type system too. And then we can actually have more dampening going on, for a nice cruise. You're not really going to that sports suspension systems like that too. We're looking at all kinds of things, and it also ties into your autonomous vehicles too. So the newer vehicles have the autonomous capabilities on that too. So it takes over the steering, it takes over the suspension system and stuff like that too. But there's typical sensors that are involved in this. We got load sensors, vehicle speed, steering wheels position sensors, and throttle position sensors also. So the control unit actually looks at all these inputs just like it would for your fuel injection system on your car, your ABS system on your car too. This would look at it and see where the command would be. So if we have, let's say, a lower wheel, it might bring it back up to the right height, either through an air control or hydraulic flow to that shock to make it work properly. And then, the steering part of it, like I said before, is going more and more electric. So we have sensors on that system also to the driver demand versus where it actually is going. If you're going at a higher speed, you really don't want that same movement of the steering. It may slow it down a little bit to get into the next lane of traffic and stuff like that. So there's different types of steering mechanisms as we go across. And then when you go into a performance mode and you're going to go into the corner, you have the capability at a higher speed to go into a squatting to get a better, lower center of gravity to get that maneuverability as you go across too. So it's looking at all kinds of different systems. It's going to make sure that if we're talking about hydraulic systems, it's going to restrict the amount of power steering output. It's going to dump the extra power steering fluid back to the reservoir instead of letting it go through and directly to that wheel and give that a quick little movement over to the next lane. Then some newer vehicles, getting to be more and more common, is going to electric steer, and it uses almost the same type of sensors, but now it just uses an electric motor versus using hydraulic fluid to actually move that ram back and forth. So this is getting to be more common. These are high voltage systems, and you want to make sure you take caution with them also. All right, and then talking about the electric steering, definitely it takes inputs from from you, the driver, and it also takes inputs from the road and the speed of the vehicle, and it transmits that to how much do we need to one side to another, or are we okay? We're just going straight ahead. So all that is very normal. Let's put it that way. All right, folks, I hope this was beneficial. I'm going to go ahead and stop sharing this. I'm going to go ahead and stop the video at this point. If you have any questions, feel free to contact me through the inbox, and I will be seeing you soon. Take care, and I'll see you. Bye for now.